My keynote today is about Redis for all your real-time data. Real-time is not just nice to have anymore. It is an expectation. It is what sets a good user experience apart from a great one. Such a great experience happens when your app responds to every operation at the latency of no more than 100 milliseconds, or 0.1 second. Measure from the time you click the button until you get the first byte of the response. Be it browsing, simple browsing, adding new item to your shopping cart, buying shares, doing comprehensive search, or even complex analytic queries. In my keynote today, I would like to show you how you can build, deploy, and run a true real-time application on the top of Redis, and why Redis is the best option when real-time matters. But before diving in, let me first list the 3 main challenges with designing an application for real-time era. Number 1, database latency. A rule of thumb of running an application in production says every millisecond spent in the database means 100 times that number of milliseconds felt at the application level. Even a 10 millisecond database response may not be enough for your application because that implies at least 1 second of application latency, which is unacceptable today. The only way to guarantee end-to-end latency of 100 milliseconds is to use a database that processes all type of operation in less than a millisecond. Challenge number 2 is the freedom to build your application with any data model. Microservices architecture has many advantages. You want the freedom and the flexibility where every microservice uses the best data model. Be it a key value for managing your sessions or doing fast lookups, document for managing profiles, stream for processing streams data, graph for managing relations, and time series for IoT and time-driven data. So if you are building a modern application for the real-time world, you need to make sure you have all the supported tools to design, develop, debug, and test your application with this modern data model. And the last challenge is deploying a globally distributed application and running them with little or no latency. In the world of containers, Kubernetes, and hundreds of public cloud regions, zones, and hybrid deployment options, you can practically deploy a fully distributed application anywhere in minutes, as close as possible to where your users are, and provide a true real-time experience. But there is one challenge left. A stateful real-time application requires real-time access to data. How you can provide this access with ultra-low latency if your application is globally deployed? Let's deal with challenge number 1. So many benchmarks have proven that Redis can process any kind of operation, simple or complex, with sub-millisecond response time, even if performing millions of operations simultaneously. With over 10 years of being in the most demanding production environments across the globe, in every vertical, we have been steadily expanding Redis capabilities beyond cache to provide all the essentials ingredient of modern database to meet the needs of Redis users, such as replication with high availability, failover, clustering, data persistence, backup, and built-in security feature. Not to mention advanced Redis enterprise capabilities that allow you to run Redis with 5 nines availability using active technology and Redis on Flash to store terabytes of data at the cost of disk-based database. And let's take a minute to share with you our production history. We are over 9 years in production with over 1.5 million databases created, deploying across more than 500 cloud and on-premises data centers, and experience over 5,000 node failure events and over 200 complete data center outages with no notable data loss. And this is why over 66% of our users are using Redis Enterprise for beyond cache use cases. One area of continued investment is to offer Redis with strong consistency. Last year, we announced a project called Redis Raft, which allows you to run Redis using Raft consensus algorithm, making Redis a proven CP system. Since then, we have made exciting progress. Let me just summarize what we have done so far with Redis Raft. We passed the Jepson test with no unresolved issues. With the support of clustering, you can easily reach to over 100,000 strong consistency transactions per second by adding the right number of shards. As for latency, we plan to provide two options for Redis Raft. The first, with asynchronous disk write, you can maintain the sub-millisecond latency of Redis. The second, with synchronous disk write, you can guarantee full durability even if the majority of the cluster node fail, while still maintaining the single-digit millisecond latency of Redis, meaning less than 10 milliseconds. We are now previewing Redis Raft with some of the largest financial services on Earth, making sure it is ready to meet the need of most demanding environment. And today, I am happy to announce that later this year, as part of Redis 7, Redis Raft is going to be GA. Many of you in the audience are here to learn and explore how you can build the fastest application more quickly with Redis. Redis is not just a data structure server anymore. Since the introduction of Redis modules in Redis 4.0, we have been working to transfer Redis into a full-blown modern data model server. With this new reality, you can build fastest application by moving more and more workloads to Redis. And you can even build them quickly. We are constantly improving our development tool, like Redis Insight, and adding new capabilities to the leading Redis client. Let me share with you a bit about these modern Redis data models. Redis Search lets you index query your Redis data. You can also perform full-text search with the speed of an in-memory database. Redis JSON lets you manage JSON and the rich nested document model it provides in Redis. Redis Graph allows you to model and query relation in Redis, turning Redis into a high-performance graph database. Redis Time Series let you monitor IoT devices and analyze time series data. And with Redis Bloom, you can create as close to accurate estimation with minimal memory and CPU usage. We are seeing adoption across all these data models. However, JSON and search definitely stand out. For quite some time, Redis users have been asking us to let them query their JSON data using Redis Search. So today I am happy to announce that the combination of Redis JSON with Redis Search is going to be preview next month. This will allow you to index, query, and search in JSON documents stored in Redis at the Redis speed. To demonstrate how it works, I would like to invite Peter Caillou, Director of PM for Developers Experience, to the virtual stage. Peter, welcome.
Thank you, Yiftach. Before diving into the demo combining Redis Search and Redis JSON, I would like to touch upon the improved architecture in Redis Search 2.0. Prior to 2.0, you had to use a specific command ft-add to index data into Redis Search, and Redis Search on turn optionally would write that data into Redis. From 2.0 onwards, you can use the default core commands within Redis for manipulating hashes. You can then create, update, and delete those with the regular commands. You then define a schema within Redis Search, and Redis Search will follow all these updates within your database. Effectively, Redis Search 2.0 is a secondary index for your data residing within Redis. There's no need to update any existing create, update, and delete logic. You can simply add Redis Search, define a schema, and start querying. With this change architecture, we can also add other data structures to be able to be supported by Redis Search. We thought about strings because many of you use them for caching purposes. We thought about streams to index all the messages. We thought about time series data, because time series, they have labels and sometimes require fuzzy searches. But we also thought about JSON. JSON, as pointed out by Yiftach, is our most popular module. From our community, we learned that many of you effectively were looking for full-text search querying on top of JSON documents. So let's jump into the demo. I'll first look into which modules are loaded within my database. There is search and JSON, as you can see. We look at the keys within our database. We have 5 documents. I will use Redis Insight to look into those keys. Redis Insight is a graphical user interface to help developers to be more productive building applications. So let's look at, for example, at product 2. We can see there's an ID, a SKU, a name, a short description, long description, a price, several categories, a rating, and an image. What we're going to do is to build an index on top of our product catalog so we can search these products. All these products, by the way, are headphones. So let's start with creating the index. My index name will be IDX product. Next thing I need to specify is the data structure on JSON. We also support on hashes. The next thing is we need to tell Redis Search which keys it should index. All the ones that start with a prefix prod. And lastly, we need to define the schema. We will index 2 fields, the name and the long description. And we also give them an alias. Notice also that we use the full JSON path expression, $.name, to specify which field within the document we would like to index. So let's start searching. We're looking for a product that contains base. So let's go ahead. So there we go, we find product 4 effectively having a base within this product name. Let's continue with a fuzzy search. Let's look for wireless within our product catalog. So headphones that have a wireless connection. So there we go, we found 2 matches that contain wireless within the description. Now let's do something more advanced. Let's search again for wireless, but let's do a projection. Let's return just the product name, but also the price. So with this, we effectively can show that we can do full text searches, fuzzy searches, and even projection. There is much more to it. We can also do aggregations and pipelines on top of your dataset. Back to the slides. So the last question you could ask is it fast? So we have some preliminary benchmark data. We used the Yahoo Cloud Serving benchmark for the e-commerce use case to benchmark Redis Search. And we compared it to the most popular document databases. And we can see that Redis Search is 3 to 37 times faster. Imagine how that will change your user experience for your applications and which cost savings you can do with that performance increase. So when will it be available? Redis Search and Redis JSON will go into private preview next month. Back to you, Yiftach.
Thank you, Peter. Now let's talk about how you can use Redis to deploy real-time application with real-time data. The combination of JSON plus search allows you to build almost any application on the top of Redis and make it run extremely fast, say 50 milliseconds from the time your user request arrives to your application servers until your application responds back, including multiple interactions with Redis. But what about the network overhead? How can you make sure all the work you have done to build a real-time application is not degraded by the network latency? And how can you guarantee that end-to-end latency of your app will not exceed the 100 milliseconds? So let's examine together several deployment options. Option number 1 is to use one central primary Redis instance with multiple read replica. This can work nicely with read-only workload, but this architecture can result in write bottlenecks, threatening the entire real-time experience of your application. Option 2, deploy your application, use commonly available globally distributed database, and use Redis as a local cache solution at each replica. First, this architecture is extremely expensive and complex, as it requires deploying multiple data stores in each geolocation, building all the connection between them, and running multiple clients at your application server. Second, globally distributed databases like Google Spanner, AWS DynamoDB, and Azure Cosmos DB rely on a consensus protocol to provide some level of consistency, be it strong or eventual consistency. This means that every read or write operations need to run through the majority of replicas across the globe, which again may break the real-time nature of your application. Option number 3 is to use active-active Redis. Active-active Redis lets you deploy a distributed replicated Redis globally, while always permitting the local speed of read and writes. This means the fastest possible local response times. What makes active-active Redis possible are CRDTs, or conflict-free replication data types. This technology means that an active-active deployment doesn't need a consensus protocol, which is great for application developers because they can perform read and writes at the local sub-millisecond speed of Redis without worrying about consistency. Based on years of academic research, CRDTs guarantee that eventually all your write will be converged in a conflict-free manner across all your replica. And today, I am happy to announce that we have extended CRDTs to support the nested data type of Redis. Running Redis JSON plus Redis search in active-active deployments will be generally available at the beginning of the second half this year. Now let's see how easy it is to deploy a distributed Redis database powered by Redis JSON and Redis Search across all 3 major public clouds, AWS, Azure, and Google Cloud. For this, I would like to invite Jonathan Salomon, Senior PM for Redis Enterprise Cloud. Jonathan, welcome.
Yeah, thanks, Yiftach. So let me walk you through how simple it is indeed to create an active-active Redis subscription with modules on Redis Cloud. So let's start off by creating a new subscription in our flexible pricing tier. And after enabling active-active Redis, we can now select the same regions as where our application is running across cloud vendors. So let's go with these default regions for now. And having given the subscription a name, we can now continue and define the sizing requirements for our subscription. So I'm going to add here a database and name it after our application. Set a memory limit of 25 gigabytes. And for each of the regions that we defined in the previous phase, we can here set the throughput requirements. So let's go with these values. And since our application is relying on the combined power of both Redis Search and Redis JSON, I'm going to add these modules in here right now. So now that we've saved these settings, we can continue and review together what we're about to provision. So we see here an active-active Redis subscription that's going to provision across these regions and these cloud vendors. And here we can see the number of shards and their cost for each of the regions. As this is what we need, let's provision. So this step may take a few minutes. Therefore, I'm going to switch now to another tab where we have a ready-to-go subscription waiting for us. Now, as we can see here, we have a map that's showing us the regions that are part of this active-active Redis subscription, and it's showing us some of the main metrics. So let's see what happens when we connect our clients and we start loading our application dataset. So hold on 1 second while I go do that. Right. So now as the data is being loaded, we can see that the memory used and the number of keys are rapidly increasing, while the local latency of the participating regions effectively remains below 1 millisecond. So Yiftach, I hope this little walkthrough shows how easy it is to quickly deploy the active-active technology across multiple regions on Redis Cloud.
Thank you, Jonathan. Now it's about time to see how all the technology we have just described come together and help us to build the most responsive application on the planet. For this, we have built an e-commerce application called Redis Smart that relies 100% on Redis. Deployed and run across multiple clouds using active-active Redis technology, Redis Smart leverages the combination of JSON and search. To demonstrate the application, I am welcoming Ash Sahu, Director of Product Marketing, to show you how it feels when your e-commerce application executes every operation in real time. Ash, over to you.
Thanks, Yiftach. I'm Ash. I'm going to demo how you can use Redis JSON with Redis Search to build real-time applications with interactive search experiences. So as Yiftach mentioned, we've actually created a fictitious retailer called Redis Mart that sells electronics, appliances, and other items. It's actually a fully functional e-commerce store built entirely on Redis. So I'm going to I'm actually looking to buy a movie to watch with my son. So either I can click on the category or I can go to the search bar and search for movies. In fact, 30% of shoppers use the search bar to find what they're looking for. So the search has to be fast but also typo resistant. Let's talk a little bit about speed. I'm going to open this console and look at the performance. This page is dynamically constructed using data coming through an API from the server. What I'm trying to do is narrow down my search using this faceted navigation on the left hand side. I'm going to make it a little bit more reasonably priced. I want a higher rated movie, and I'm going to narrow it down to just movies and TV shows. Well, if you see the number, keep an eye on the number on the right hand side, you'll see that it's less than 100 milliseconds. This is the time to first byte, which means that complete end-to-end latency. Below 100 milliseconds is actually blazing fast. And you may wonder what's the big deal about 100 milliseconds versus 1 second. In fact, research has shown that if the performance slows down from 100 milliseconds to 400 milliseconds, then it has measurable impact on users. Now, as more and more users and businesses are going online, a faster performance means a better online shopping, a better digital banking, a better telehealth experience, which leads to more usage and more satisfied users. The speed really matters. I'm going to close this now, and we're going to go behind the scenes to see what's happening on Redis. First thing I want to show you is the JSON document which is sent back. Now, JSON is the lingua franca of the internet. 80% of modern applications use JSON as data format, mainly because it's flexible, it's intuitive, it's used in the application layer, so it's very developer friendly. Now, Redis JSON supports store and query rich nested JSON documents. It also supports atomic operations on this nested documents, so you don't have to load processing the application layer and reload things again. Let's look at what the search query really did. So FT search is powered really is by Redis Search, and Redis Search is our secondary index and full text search engine for hashes. And as Yiftach and Peter just announced, it also supports JSON documents now. This means that you can run exact text, fuzzy search, prefix phonetic stemming, and a bunch of other full text search functions using this one unified API that's purpose built for performance. In fact, it also rapidly indexes frequently changing data sets, so you never have to return back stale data. Below that is the FT aggregate command, which allows you to run simple analytics. And in this case, you're actually constructing those filters dynamically from that aggregation of all the items coming back thanks to that search. So Redis JSON and with Redis Search is really a game changer. It brings millisecond latencies, even during seasonal peaks like Black Friday and Cyber Monday. Now I'm going to find what I'm looking for finally. So here is here's a Safari. We just got back from Safari. My kid's into wildlife. This will be interesting for him to watch. I'm going to add it to the cart. I'm also going to look for headphones so I can work while we're watching the movie. I'm going to highly rated headphones, a little bit more higher end. This black one looks great. I'm going to add it to my cart. I'm going to check it out. Now you can see this local pickup. So Redis Mart supports buying online and picking up curbside or at the store. And this lookup is powered by Redis Search. In fact, you can use Redis Search not just for searching by text or numeric filters, but also do geospatial searches, so you can find the stores closest to you. So that's because of Redis search. Now I'm going to shift gears a little bit before I place the order, because I want to talk to you a little bit about how Redis Smart was deployed and give you a retailer's point of view. So Redis Smart is deployed across 3 different geographical areas. One is in US Central on Google Cloud. The other one is on US East on AWS. And the last one is on Azure in Northern Europe. I'm actually opened the inventory page for Redis for the Azure location, because I want to show you how you can how data is being synchronized using active technology. So let's go and split screen this, and I'm going to pull it up, and I want you to keep an eye on the amount on this speakers which are in of these headphones which were in my shopping cart. And as soon as I place the order, you can see that amount got reduced in stock from 65 to 64. Now that happened almost instantaneously. These 2 data centers with the application and the database are almost 5,000 miles apart. So Active allowed you to synchronize data across different geographical areas, but also across different cloud providers. Now you may be wondering, hey, what's it seems like a small feature. Actually, this is quite a big deal. This enables retailers to implement real-time inventory management, so they can get more accurate view of their inventory or avoid stockouts. You can do inventory optimization, so they can actually fulfill orders from nearby stores. This was not possible before because their existing backend systems are not really built for the real-time era, and they're slow, and all processing happens in a batch process. Well, this wraps up my demo. I want to just summarize by saying that Redis JSON with Redis Search can help you build real-time applications, power real-time search, and get real results. All right, back to you, Yiftach. Thanks so much. Bye.
Very impressive, Ash. Thank you. Now let's assume that you want to enrich your application with some AI capabilities. And in the context of an e-commerce application like Redis Smart, you want to add a visual search, the number 1 desired feature by e-commerce customers. Normally, this would require introducing an all-new technology stack. But it turned out you can do it with Redis too, and maintain the real-time experience we are aiming for. Before getting to all the details, what is running behind the scene, let's first get back to Ash to show us that this can actually work in real application. Ash, please.
Thanks, Yiftach. Well, we're back for one more thing. It'll be quick. I'm going to show you how visual search works on Redis Smart. So I'm going to click the camera button. It'll open up the webcam on my computer, and I'm going to try to look for these headphones. So I'm going to scroll up and click capture. Well, you can see the similarity search returned back 4 results. In fact, the first one is actually a headphone similar to mine. So it's done a good job of identifying my headphone and finding similar ones in the product catalog. The other one's also not bad. They have similar contours at the headphone. So now back to Yiftach to explain how Redis AI works and how it seamlessly integrates into your Redis technology stack. So back to you, Yiftach.
Thanks again, Ash. So how does visual search works? In essence, it's powered by a few technologies. These include Redis JSON and Redis Search, which we have already mentioned today. But in addition, there is Redis Gears, our server-side execution framework or programmability engine, and Redis AI, which brings real-time inferencing to Redis. Here is how it works. Every image is translated to a vector. These vectors are stored in JSON and indexed by Redis Search. Under the hood in Redis, the client calls Redis Gears functions with a reference to an image. Gear passes the image to Redis AI, which translates it to a vector. Gears then call Redis Search with the image vector. Redis Search performs a similarity search and return the URL for the images that are nearby in the vector space. Let's take a closer look how long it takes to execute this flow. The inferencing phase, in which Redis AI translates an image to a vector, takes around 300 microseconds. Our vector similarity search algorithms works in a near constant time of no more than 500 microseconds, even with a collection of millions of images. And finally, the gears functions overhead is around just 100 microseconds. This brings us to a total processing time of 900 microseconds, so we are still under the millisecond. And this is how powerful Redis is for real-time AI use cases. Even after adding some non-trivial AI functionality to the stack, the processing time didn't go beyond a single millisecond. But before talking about what else you can do with Redis for real-time AI, one of the things we learned by analyzing many of our customers' use cases throughout the years, and as nicely illustrated by this example, is the importance of programmability options for Redis users. So today, we would like to introduce Redis Function, a new concept and capability that we plan to add to Redis 7. To talk more about Redis Functions, I would like to welcome Yossi Gottlieb, one of our Redis open source project leads. Yossi, the floor is yours.
Thanks, Yiftach. So I want to start by looking at the different programmability options that Redis offers today. Most people are familiar with Lua scripts. They're really the simplest and the easiest way to program Redis. They involve applications sending Lua code to the server to execute on the server side. That code executes atomically and also saves the network round trip, so it can serve as a way to optimize certain operations. But conceptually, Lua scripts are really part of the application. They are not managed as individual entities on the server, so they don't extend Redis. If we want to extend Redis, then our best option is modules, which are really very, very powerful, but they are also pretty complex and may involve a pretty steep learning curve for many developers. So in between, we see the Redis Gears module, which is not part of the Redis open source core itself, but part of the greater ecosystem. It was created to address specific data integration scenarios. But it does offer a way to extend Redis in a rather simple way. And when we discuss this with users and users in the community, we realized that it would be very useful for the Redis core itself to adopt some of these capabilities. And so we started to sketch different solutions and prototype them, and we got eventually to the definition of Redis functions. So Redis functions basically have two main characteristics to them. One is that they are managed by the server. They are once you create a function, it gets persisted on the server. It gets replicated to replicas. It is named, and your clients can call it and access it by name. The other aspect of a function is that they are built on the concept of execution engine. So we basically separate the concept of loading code into Redis from the specific details of what engine is used to run that code. So that code could be Lua scripts, could be Lua if we want to turn Lua scripts into Redis functions, but it could also be something else now or in the future. Let's see how this works in action. So I will assume that my Redis is a backend database for some kind of an e-commerce site, and I'm going to manage my product catalog on Redis. So I have hash keys for my products with a description and all the metadata that describes the different products. And I will also use Redis to store my runtime shopping cart state. So for example, if I want to put some product in a cart, I will do something like h buy into my cart key, the product ID and the quantity, and then I can always fetch it, and that's really very simple. Then one day I may want to extend this with some additional logic. For example, I could want something like a max quantity property defined per product and enforced whenever that product is being placed in shopping carts. So, and of course this logic needs to be executed atomically, preferably on the server side. And the easiest way to do that would be to create some kind of a Lua script. Really pretty simple, that just gets the cart key and product key and an optional quantity that can default to 1. Get the product hash key, make sure that it exists, then look at the cart, fetch the current quantity of this product in the cart, compute or adjust the quantity based on the max quantity, modify the cart if necessary, and return the adjusted quantity. So that's really just a few lines of Lua code. It's very simple. I can run it with something like Redis CLI -eval, or use whatever script execution mechanism my Redis client library offers. And in this case, I will I will add to the existing cart, and I will use the existing product, and I will not specify the quantity, so it's 1. But at some point, I reach the max quantity, and then I see that it's not getting added anymore. The problem with this approach is that this Lua script is really part of my client application. So whenever I change it, I need to deploy it to as part of my client application. And if my application spans a lot of different hosts, or maybe even implemented as different modules on different technology stacks, that can be much more difficult to manage. Especially if my changes require or involve some kind of backwards compatibility issues, the data structures change, etc. So if I want to turn this into a function instead, I can do something like Redis CLI function create. I need to specify the execution engine for my function. That will be Lua, because this is Lua code. I need to name my function. I can optionally describe it. That could also be a more elaborate description, including what arguments it takes and return what return value is expected to return, etc. And then I will use -x and redirect for my cart add Lua, and I have a new Redis function created. And now I can call it function call and the name of my function, but actually I want to do something else. I want to show you the same function implemented as a different on top of a different execution engine. So I will, instead of calling it, I will do something like function delete cart add and get rid of my function. And instead I will I've prepared in advance another implementation that is basically the same thing but in JavaScript, right? And I will do something like Redis CLI function. I can use this and just change Lua to JavaScript, and change the name of my file to cart.add.js, and now I have a JavaScript function. And I can call it function call cart add. I need to let's pick. I need to specify the number of key arguments. And I will pick a new cart, and I will pick the same product, and I will add it, and I see that I get 1. And if I'm trying to use some kind of extremely high quantity, I see that it gets adjusted. And of course, if I try to use a non-existing product, then I get the JavaScript exception thrown and converted into a Redis protocol error. So that's what Redis functions are in a nutshell. And just to recap, so basically they enable us to load code into Redis. We unlike Lua, that code becomes part of the server. It is named, it is persisted and replicated, etc. And the actual execution engine is kept relatively decoupled, so we can have different functions being implemented using different development tools or different programming languages, and that could also be extended in the future. With that, Yiftach, I return to you.
Thank you, Yossi, and we are looking forward to hearing your feedback on the Redis function concept. Let's return to Redis and the real-time AI. Companies like Uber, Gojek, DoorDash, Netflix, Spotify, Airbnb, and many others have started to share their AI reference architectures. And at the heart of these architectures, there is one component that stands out: the feature store. Feature store have been motivated by the challenges of taking AI application to production, and were built as a bridge between your data and your machine learning models, to allow you to register, ingest, serve, and monitor features in production. There are two main components for every feature store. Data orchestration, where data scientists build, track, and share features for training and inferencing. This component helps, among several other capabilities, to improve the data quality. Data serving component is where the features are stored and served. An offline feature store is used for the training phase, while an online feature store is used for the production and the inferencing phase. Now you may ask yourself, this is all great stuff, but why this is related to Redis? We have recently found that in most of these AI reference architectures, Redis serves as an online feature store. Let's dive in and understand how Redis is being leveraged as an online feature store. Modules may have been trained with hundreds or thousands of features, but an online application, like a fraud detection example, may just receive a few of those features from the user interaction. In this fraud detection example, the user ID and merchant ID. The online feature store is used by the real-time application to look up for the missing feature. In the fraud detection case, this can be user history, the merchant history, the geolocation, and many others. And then build a feature vector and send it to the inferencing engine for predictions. There are several reasons why this architecture is still not perfect, but what can be seen very clearly is that it requires a lot of interaction between multiple components and eventually increases application latency. This is why we built Redis AI, to run the inferencing logic closer to where your AI features live, which simplifies the architecture and dramatically cut latencies. Furthermore, many of today's AI architecture are not only based on a single AI model with multiple features. Some applications use multiple models per application. For these use cases, you need to be able, first, to have a model store, and second, make sure that switching between models is done in a very fast manner, at the memory speed, so user can be served with the logic tailored for their specific need. So Redis as an online feature store now includes a feature store, a model store, and an AI inferencing engine. But we don't stop here. During the rest of the year, we plan to add the following capabilities to Redis to support the growing demands for an online feature store. Feature monitoring that will allow you to monitor which feature is used by whom and when. Drift monitoring will help you to improve the accuracy of your models. We will then add a sync mechanism or sync mechanisms from Redis to any popular offline feature stores and vice versa to maintain the consistency across features. We also plan to tighten the integration with Feast, an open source for feature store that already uses Redis for basic online feature store capability. We also plan to tighten the integration with commercial feature store providers. And remember, our primary motivation here is to help you to build AI-based application for the real-time era. And here is a reminder how an online feature store's performance based on Redis plus Redis AI looks like compared to using Redis with different type of inference engines, deployed far from where the features are stored. This combination of reduced latency and increased throughput allows Redis plus Redis AI to be an order of magnitude or 2 orders of magnitude faster. So let me summarize what we discussed in this keynote. Real-time is essential for every business these days, and Redis is what makes real-time possible. This is why over 66% of our customers rely on Redis as their main database, and why we decided to make Redis suitable for use cases where strong consistency is a requirement. Redis Raft is going to be GA this fall. Many of you are looking to build everything with Redis. We want to enable you doing so by making our JSON data type accessible through fast indexing, query, and search engine. The combination of JSON and search will be in preview next month. Furthermore, at the beginning of the second half of this year, you will be able to deploy and run Redis JSON and Redis Search database in a fully managed manner across multiple regions, cloud, and hybrid deployments, closer to where your users are, using active Redis. The combination of Redis Gears and Redis AIs allows you to almost do anything, any functionality to your application stack, without affecting the real-time experience of your users. And Visual Cert is just one example. Starting from the second quarter of this year, we are going to release Redis AI and Redis Gear in a gradual manner on Redis Enterprise Cloud, our fully managed cloud service. With the introduction of Redis functions, programmability in Redis is going to be easier than ever. Redis functions are going to be available as part of Redis 7 later this year. And finally, Redis as an online feature store combined with model store and Redis AI inferencing engine solves a lot of real-time problems of bringing AI application to production. We are going to be very active in this area, so stay tuned. Thank you very much. Hope you enjoyed the session. And please remember, RedisConf is a great place to learn more from other Redis community members, how they use Redis to build, deploy, and run real-time services and applications.